zindu chungni lubru tsangma la touch dile ta de thari nga zo transcription gi video niwa di nanglo la nga zo khar khar ga la jangre lawo yimbai na ro thangbo di nga zo khar ga jangre la na transcription process shorwa di gi general overview sta che ro ani di jela ani process of transcription in prokaryotes and process of transcription in eukaryotes khuni ni para la khewa khardo prokaryotic cell nanglo la transcription khandis chungore ani eukaryotic cell nanglo la transcription process di khande chungore khuni ni para ge khewa du go chho chenda. Okay, so thangbo ding azu khare the process of transcription a general overview. So the transcription ki definition ye khala so. A copying of one of the strands of DNA into RNA is called as transcription. DNA ki information di RNA la pha gyurgu yobi imbai na dila transcription la wores la so. So RNA nanglo la remember RNA la rigmanda sum yorta. Ngazu ha ko RNA la rigmanda sum yore khare khare la na mRNA, tRNA, rRNA. So mRNA stands for messenger RNA, tRNA stands for transfer RNA, rRNA stands for ribosomal RNA. So mRNA la digi lengge kharelana it provides the template for protein synthesis. Cell nanglo la protein so wala mRNA inji miji gugore. mRNA it carries the information for the protein synthesis. It provides the template for the protein synthesis. tRNA ki lega khare tRNA it's like an adapter molecule. Shuma translation na wekira zo jangre. tRNA ki kharchi gore koi ki mingora khare transfer RNA to koi ki chik transport chigora koi khari transport chigora khari transfer chigora la imba na amino acid ki ongor. Ribosomes ki protein sudu zambala during translation. Ribosomes ki protein sudu zambala protein suwala amino acids ku gorwa. Amino acids di ribosomes ala sui ki ongor la na tRNA ki ongor. Ani tRNA they have the ability to read the genetic code present on the mRNA. Then rRNA dikhare ribosomal RNA. So these ribosomal RNA they have got catalytic role. Ribosomal RNA the enzyme nangshi lega chigre ko protein member la enzyme nangshi lega chigre. So they have got catalytic role. Ko reaction catalyze chigre reaction kyo orta hai chomarwe di chigre. And nyamdola it also plays structural role because ribosomes they are made up of proteins plus rRNA. Ribonucleic acid ki soy orta. So it also plays structural role. So dige sum khare the types of RNA. Right. So all these three types of RNA are required for protein synthesis. Cell nanglo protein sewala DNA nyamdo landio khar khar gudo RNA dige sumja gudo ribosome protein setu wala ro DNA information di su kyungudo mRNA kyungudo amino acid su kyungudo tRNA kyungudo ani ribosome khorang khari gi soyoresha rRNA da protein gi soyorodo. So all these three RNAs are required for protein synthesis. So transcription la di kechembo khajin chagore law imbana DNA ne RNA gyure gi process di khajin kechembo re law imbana protein soyache to ani protein soyache to RNA di gi sumja gudo. Okay, diche tang azu gi general overview ta du zambala process of transcription khandis chungo re law imbana. First of all we have got the information for protein present on the DNA. DNA is a double stranded molecule. So DNA di nanglo la protein soyag information diyor. So protein soyala thangbu khari chegu gore RNA la gyurgu gore. So transcription step de thangbu li gore. So RNA soyala the main enzyme which is responsible for making RNA soyala enzyme kharu gore na RNA polymerase la di gore tel RNA polymerase la di do. So this enzyme is required for the polymerization of new RNA based upon DNA. DNA gal information khardu tani ro RNA soythunge gi nuba de sul yorla na RNA polymerase enzyme de la yor. So RNA polymerase di kharchigre DNA gi segment gala jar. It will go and attach itself to the DNA segment which needs to be transcribed. Right? Kogala jar ani ko khachigdo. It opens up the DNA. DNA this khachigdo. Such a chunjula DNA khachesha do it opens up. Di para de la hydrogen bond de samo ko chani DNA this opens do. DNA opens so jela on the template strand ngazulo coding strand the template strand la ni yo DNA nangola. So on the template strand template strand la shisha ni ro ani ko kharchigre it will start synthesizing RNA molecule RNA sugre. So dila ngazu khalla ore transcription process la oro ani ko RNA soba lo kola kharu gor la imba na nucleoside triphosphate substrate gor. So enzyme reaction chik chewa lo kola substrate gorwa. So substrate di kharcha do ore nucleoside triphosphate the cell gi nanglo yo bare so kharchi re nucleoside triphosphate re leni ko gani digala jargi chi ko gi sequence ti khargi shisun jargi re lawo imba na coding strand gala base sequence kharre sho odi shisun jargi re seu chung so ani ko gi di nanglo la RNA sudu zamba la RNA thundu chuma do de la jar yo marta shimba sama kharchi do free RNA chin ma chilol ma thön ru do so enzyme nanglo la DNA da RNA ga ji complex choro DNA RNA hybrid region jo mara di chunju chuma do yo mar only few bases are attached over here rest are free and they will detach and they will go outside so the RNA process ka ji do RNA synthesize che gi process transcription ka ji gi general overview di charda RNA polymerase yong ne jar ani RNA sawa soya ji do the process di ani nge gi khalla so RNA polymerase la nuba khare yor la so limitation ta nuba la or limitation la or RNA polymerase can synthesize a new RNA molecule only in 5 prime to 3 prime direction 3 prime to 5 prime direction la soya gi nuba yo marda so RNA polymerase it has to move in this particular direction polymerase movement la ne da di pha tyon do ti tyon go yumzen khare la na RNA polymerase it can synthesize the new RNA molecule only in 5 prime to 3 prime direction so di kharchi ni me de kyan zen do thowa na jang so di chemistry de jawa cha du okay tiche ta next nga zo kharta gre law imba na the differences between transcription in prokaryotes and transcription in eukaryotes prokaryotic cell nanglo la transcription contest chungu do eukaryotic cell nanglo la transcription contest chungu do khuni ni paragi khewa dirda okay so thangbo dinga zo kharta gre transcription in prokaryotes bacteria nanglo la bacteria nanglo la transcription contest chungu do hitayar da so transcription in prokaryotes nanglo la kyan zo bacteria samlo tan dir E. coli cell samlo tan dir E. coli bacteria ro so din nanglo la information thangbo dikhare la win bana prokaryotic cells nanglo la bacteria nanglo la there is only one RNA polymerase DNA dependent RNA polymerase chigma do yomarda so ming DNA dependent RNA polymerase lar ma do del ya khare RNA polymerase enzyme di chadu wor so RNA polymerase there is only one in prokaryotic cells only one type any RNA polymerase di kharchi gore RNA khamanda sumja khog sogor tRNA rRNA mRNA chama RNA polymerase chi gisogor so there is only one type of RNA polymerase inside the bacteria information niwa dikhare this enzyme is only capable of catalyzing the polymerization of nucleoside diphosphate RNA polymerase di prokaryotic cell na yo RNA polymerase la nuba chik mo dio mar ngone chena ko khari che nuba yore chain elongation polymerization che nuba mo dio mar it can only synthesize or extend the RNA molecule by adding or by polymerizing nucleoside triphosphates ta dinde hindu zambala ani khola DNA ga la jaryal rokpa switch gore DNA ne pha khodu rokpa switch gore lawa imbai na khola rokpa chingye factor near initiation factor termination factor initiation factor is also called as sigma factor termination factor is also called as rho factor so RNA polymerase chi gyo jorwa ko kisi transcription chewo yo wi ba no ko DNA la jar korwa so DNA la jar du zambala rokpa switch re it will be initiation factor or sigma factor the RNA polymerase khuni ni jar ni ro ani DNA ga la jar tu wor seu chung so ani ya transcription sam sha du zambala ya su rokpa chi re la wi ba na rho factor la ji rokpa chi RNA polymerase la so these are like cofactors on enzymes they require other factors for the functioning enzyme holo enzyme chawala any khargu factors guya so what is initiation factors the termination factor so ani last information the prokaryotic cell nalo la last information dikhare transcription the translation niga it will happen at the same time it can happen at the same time because prokaryotic cell nalo la nucleus yo mare nucleus medu zambala DNA cytoplasm nala yore ribosomes tenzuge cytoplasm nala yore DNA zambala transcription the translation ni nyamdo yongor indi jibo sei mare prokaryotic khaji gi genes chyo marwe ko split gene marwa eukaryotic cell di split gene imba so prokaryotic cell khaji gi genes dige split gene mendu zambala ro ani RNA de lo gyo khegu chho mar RNA DNA ga du so chawada ani sharya khora protein so go chu shana digor ani nucleus ta cytoplasm na loga medu zambala ro ani transcription the translation it can happen together at the same time so dirda these are the information kiranzo di ma notes ma shushana digdu okay so ngi da remove digala shishane thada dige sama yangyajik deshe gyanda kiranzo remove dipendenga chimbure this particular figure number 6.10 process of transcription in bacteria the process of transcription nanglola you should explain the process of transcription in bacteria in 3 steps three step kar re initiation elongation and termination dige sum inji miji changorda initiation gi kabla khar chigre lawa imbai na ro the RNA polymerase enzyme del orange dose go host thongdo so the RNA polymerase enzyme dirda so RNA polymerase enzyme it will bind to the promoter region ana di seu dire ro del seu chendo DNA strand seu chtemendwe the promoter region dire so promoter region gangla RNA polymerase di jargres lar during initiation ta ko jardu zambalo khol rokba go ringe la satanji rokba dikhare sigma factor or the initiation factor sigma factor the RNA polymerase ni di this ring la journey in khachire it will help the binding of RNA polymerase to the promoter region of the DNA promoter region gala jargre so promoter region di gala jardu zambala promoter region dela ditsa dela yogyo gi ro ani khare hydrogen bonds this chikho khachire chagre it will create a transcription bubble right so initiation lawa imbana RNA polymerase di DNA gala jarya di promoter gala jarya gi step dire inal inji minji sigma factor dimension che orda sigma factor gi role kechumure then tadigan jarsa so RNA polymerase di digala jarsa ro the next khar chigire there is elongation step new dikhare elongation ladu zambala ta RNA polymerase di jarsa ve jela sigma factor di pha kho dure ta RNA polymerase it will move in this particular direction pha move chiro so RNA polymerase di pha move chidu zambala ko khar chigire it will start synthesizing a new mRNA or RNA molecule soya ko zu this seus to the RNA molecule reda so RNA molecule kharchi gore ko polymerization chi gorwa nucleoside triphosphate ko dela gargi cheni khachi gore RNA molecule ring to gorwa so so dela kharchi re there is elongation of this new mRNA molecule ring to tichin dela ming kharta re elongation the elongation chetsawe jela when this RNA polymerase reaches the terminator region so RNA polymerase the terminator region le somebody jangu dikhare gore terminator region reda so terminator region chila lidu zambala RNA polymerase kala shimbaji khar jargire row factor la de jargir or termination factor RNA polymerase kala row factor jar di jar waking gi khachire RNA polymerase di DNA ne chu khodur it will detach itself detach chadu zambala an khachire RNA polymerase khora free chadure ani RNA sawa soigyo jora khoe free chadur seu chungswe so dikhare termination now initiation kabla RNA polymerase DNA kala jarya diche elongation di kabla RNA polymerase ke mRNA molecule sawa di ring tang do then termination didu zama khajire RNA polymerase pha khodur seu chungswa so nge gi dhanji nge dela information chikte so transcription the translation it can occur simultaneously dinge khalla gorla na RNA polymerase ki RNA sugi ro RNA de molecule ji chado digala khisi ribosome jarwa imbaina transcription da translation ni dinyamdo yungur tusuchigla ro ine eukaryote nala di yong thugo mar ting azuta chela hagu ra difference di teuchungso so now the transcription of prokaryote di keranzu remove the injimi jang lo transcription in bacteria la to figure number 6.10 and you should be able to explain this transcription process in 3 steps initiation elongation and termination and it will remain the same for transcription in eukaryotes as well right in eukaryotes nalo information khashesh thewayar information thewa khar rela na eukaryotes nalo la bacteria da manda khari ore la wembena RNA polymerase enzyme manda sumsyor RNA polymerase 1 2 and 3 RNA polymerase manda yudu zambalo konzule lega manda yor so RNA polymerase 1 gi khar chigre it will make rRNAs right ribosomal RNA sugar ribosomal RNA ki type khar gar sugar lana 28S 18S and 5.8S S stands for Svedberg unit okay ani RNA polymerase 3 ki khar chigre tRNA da 5SR RNA da snRNA small nuclear RNA sugar seuchung so di RNA polymerase 3 ki sugar da so RNA polymerase 2 lage to di ki khar sugar lana precursor of mRNA or hnRNA heterogeneous nuclear RNA the full form dikhe chimburtu da hnRNA stands for heterogeneous nuclear RNA so RNA polymerase 2 gi khar se ore mRNA gi precursor molecule dise or mRNA gi precursor molecule ming shimba ji khar yor la bena hnRNA or heterogeneous nuclear RNA ta di information thangbu di cha so prokaryote da manda kharle cha RNA polymerase rig manda sum wa prokaryotes nala rig man chigma do mewa RNA polymerase ta desi kheba shimbaji khar dure la win bai na ro eukaryotic cell nanglo la RNA sögyo jorwa precursor mRNA sögyo jomare ti shargya protein synthesis la peju cheya yomar ko thangbu khar che go la na tis gyuwa do go modification khashish do go so modification process depend nga chimburda modification process the khar khar re la win bai na splicing capping and tailing transcription chewe jela mRNA precursor the sötsawe jela precursor mRNA the peju go yomar ro precursor mRNA or heterogeneous nuclear RNA it is of no use to the cell ro ko protein söeg nuba yomar kharchin yomare la win bai na din nanglo la hnRNA din nanglo la introns ke yore exons ke yor mazul introns the go mewa so khariche go ore ko this gyuwa do go do modification do go do the modification dil khale splicing so during splicing with the presence of certain enzymes spliceosomes kharichi gire la win bai na introns dige pha ko hnRNA ne introns dige pha ko ani exons dige samma ya thu su jar gire seo chungso so dila khale gire splicing ye jela kyan zure mun na tengro capping la du zamba la khala gore hnRNA gi 5 prime end la heterogeneous nuclear RNA gi 5 prime end digala khonju gi khar gar gire la win bai na methyl guanosine triphosphate la add gar so this is called as capping or G capping methyl guanosine triphosphate is added to the 5 prime end of the hnRNA and then the last dikhare tailing la du zamba la khale gire la win bai at the 3 prime end of the hnRNA about 200 to 300 adenylate residues are added adenylic acid raw nigen sumja barala mangbu shu charshir tile tailing layer so let's see the process tige sama ju deta enda dikhare transcription step sama chik ba jigyarda ro RNA polymerase 2 the young dela jar ani khoi gi elongation che ani termination che sawe je lata dela RNA södwa the RNA di it is not a mature mRNA the mature mRNA marta dilanga ju khalle gire hnRNA layer ro heterogeneous nuclear RNA di the heterogeneous nuclear RNA sto seu orange chegesto the heterogeneous nuclear RNA re kharchin re law imban ko nanglo la exon the intron ni gayor seu dikhare exon orange dikhare intron we don't need it for translation che wala ngazula intron gugo mar so khari che gugo intron dige pha ko gugo so splicing che gor RNA splicing gi kabla orange kar dige sama ko re dige sama circle dige sama khari chong gor la na ro spliceosome den ju yong ni ro intron sama pha ko intron sama ko sa wejela ani exon sama ya thu da de continuous strand of yellow the continuous strand of khare exons ka ji gi continuous strand sir ro dila splicing che and di da nyam do la 5 prime end digala khar jarsha methyl guanosine triphosphate chargda 5 prime end dela so dila khale re capping ani dene 3 prime end dela jangu ji gardo di jangu di khar chongo re poly A tail adenylic acid mangbu shu jargila so 200 to 300 adenylic acid molecules are added over here at the 3 prime end so dila khale re tailing ani shine khar chare tadi mature mRNA char this is the messenger RNA ro RNA dila messenger RNA lag marta dila ngazo kharle ye heterogeneous nuclear RNA di gyuwa don yani khar chaso mature messenger RNA chaso ta messenger RNA di shine ani cell gi nucleus nanglo ne ma the chilola cytoplasm la ani ribosome nyamdo la jar ani shine ani protein suetur translation process di ko surur ro kesi dige sama mache wein bai na ro ani RNA di phejo yo marta protein suela da yana zu di remu di ke chamburda figure number 6.11 6.11 la is the process of transcription in eukaryotes razu remu di da di ganglo yo remu jo di ni compare ya buchia ani kunni ni para gi khewa dia bu go chwe bachia lo okay so that I think explains the process of transcription that is given in your textbook kana zo textbook na yo transcription process ta ni detail na deshe kya yo ta ngarang samju do ji ro ta kana zo yakbu go chwe share ta go ma chwe wi mana kana zo chel thiwa ta na digre okay all right